dear student, last class we discussed about the random variable and probability distribution. Now we are going to discuss about the binomial distribution. Before going to discuss about the binomial distribution, we will discuss about a Bernoulli's trials. What is Bernoulli's trials? Trials of a random experiments are said to be Bernoulli's trials if the number of trials must be finite. Number of trials must be finite. The second one is trials must be independent of each other. Next, each trial has exactly two outcomes, either success or failure. Either success or failure. Probability of success or failure remains the same in each trial. Right? So trials of a random experiment are said to be Bernoulli's trials if they satisfy the following conditions. The first one is number of trials must be finite. The second one is trials are independent of each other. Each trial has exactly two outcomes, either success or failure. Probability of success or failure remains the same in each trial. So then those trials are said to be Bernoulli's trials. Now here X is said to follow a binomial distribution. X is said to follow a binomial distribution. L denotes for number of trials. P denotes for success. X is said to follow a binomial distribution if their probability function is given by P of X is equals to R is equals to NCR into success power R into failure power N minus R, where success plus a failure is always equal to 1. This is called a binomial distribution. X is said to follow a binomial distribution, then its a probability distribution function is given by P of X is equals to R is equals to NCR into success power R into failure power N minus R. Observe here X takes the values 0, 1, 2, 3 and so on N. Those are the values of X. Now can you tell me what about their respective probabilities? Their respective probabilities is equal to NC0 into success power 0 into failure power N minus 0. Next NC1 into success power 1 into failure power N minus 1 plus NC2 into success power 2 into failure power N minus 2 and next NC3 into success power 3 into failure power N minus 3 and so on. Finally NCN into success power N into failure power N minus N. So this is about the binomial distribution. Now here also you can observe the total sum of the probabilities is always equal to 1. How? Just check this total sum. That means I am asking P of X is equal to 0 plus P of X is equals to 1 plus P of X is equals to 2 plus P of X is equal to 3 plus and so on plus P of X is equals to N. Sum of the probabilities we have to get 1. You can check this is equals to NC0 into P power 0 into Q power N minus 0 plus NC1 into P power 1 into Q to the power of N minus 1 plus NC2 into P power 2 into Q power N minus 2 plus and so on plus NCN into P power N into Q power N minus N. So this is the expansion of Q plus P whole to the power of N. As we discussed, success plus failure is always equal to 1. So Q plus P is equals to 1. Sum of the probabilities you will always get 1. At the same time, you know how to find out the mean of the binomial distribution. How to find out the mean? So for finding the mean, what to do? This is the way of finding the mean of the binomial distribution. So for finding mean, what to do? Mean of the binomial distribution is given by So x values 0, 1, 2, 3 and so on n and their respective probabilities. Right? So that is NC 0 into success power 0 into failure power n minus 0, NC 1 into P power 1 into Q power n minus 1 and so on. Finally NC n into Q to the power of P to the power of n into Q power n minus n. How to find out the mean? Mean is nothing but mean is equals to, we are calling this one as expectation of x, that is equals to summation r is equals to 0 to n r into NCR into success power r into failure power n minus r. This product summation is nothing but mean. Earlier also we discussed summation pi xi, so that's why pi xi. Now I can write this one as summation r is equals to 0 to n, or we are writing 1 to n also, no issue, right? So r is equals to 1 to n. We can write this with r is r into NCR can be written as n minus 1 n by r into n minus 1 c r minus 1. I hope so everyone know about this one from the first year binomial theorem chapter or permutations and combination. NCR can be written as n by r into n minus 1 c r minus 1, right? So that's why NCR can be written as n by r into n minus 1 c r minus 1 into p to the power of r minus 1 into q power n minus r can be written as n minus 1 minus r minus 1. So here r gets cancelled. This is n and this part is p. Now the sigma depends on r, that's why n and p we can write outside. That is equals to np into summation r is equals to 1 to n minus 1 c r minus 1 into p to the power of r minus 1 into q to the power of n minus 1 minus r minus 1. Now that is nothing but np into, so what we can write this one as, this is again the expansion of q plus p whole to the power of n minus 1. So that is nothing but np. So that's why mean of the binomial distribution is given by np. Mean of the binomial distribution is given by np. In the similar way we can show variance of the binomial distribution. Variance is equals to npq. Mean of the binomial distribution is np. Variance of the binomial distribution is equal to npq. At the same time we can say mean is always greater than variance. Just observe here, I am finding mean minus variance. What is the mean of the binomial distribution? Np. Variance, just now we discussed npq. If you take np common, we are getting 1 minus q, that is equals to np into 1 minus q is nothing but p, because p plus q, success plus failure is equal to 1. So that's why np into p, that is equals to np square. Here n denotes number of trials. Number of trials must be a natural number. So this value is always greater than 0. So that's why mean is always greater than variance in a binomial distribution. So this is the way x follows binomial distribution, means we will write in this way. At the same time p of x is equals to r. Probability of getting success r times is equals to NCR into success power r into failure to the power of n minus r. So that is about the binomial distribution. Mean of the binomial distribution is np. Variance is equal to npq. Just we have a few applications discussion here. So this is the first question. He is asking to find a die is thrown 6 times. A die is thrown 6 times. Getting odd number is considered as a success. Getting odd number is considered as a success, right? and he is asking what is the probability of 5 successes. We have to get success 5 times. Next he is asking P of x greater than or equals to 5. Number of successes greater than or equals to 5. And next he is asking at most 5 successes. At most 5. That means P of x less than or equals to 5. Maximum 5 successes. So that we have to find out. Getting an odd number is considered as a success when a die is rolled. When a die is rolled, getting an odd number means we have to get 1 or 3 or 5. That's why success probability is equal to 3 by 6, that is equals to 1 by 2, whereas the failure is also equal to 1 by 2. Number of trials is equals to n, that is equal to 6, because a die is thrown 6 times. Now P of x is equals to 5 is n. Out of 6 trials, we have to get 5 times success. Out of 6 trials, we have to get 5 times success. Success 5 times. Failure remaining times 6 minus 5. Next he is asking P of x greater than or equals to 5. P of x greater than or equals to 5 means we have to find out P of x is equals to 5 plus P of x is equal to 6. Now that is given by 6c 5 into 1 by 2 whole to the power of 5, success 5 times, into 1 by 2 whole to the power of 6 minus 5, remaining times failure. Next plus 6c 6 into 1 by 2 whole to the power of 6 into 1 by 2 whole to the power of 6 minus 6. Next he is asking probability of getting at most 5 successes. Number of successes must be less than or equal to 5. So we have to find out P of x is equal to 0 plus P of x is equals to 1 plus P of x is equals to 2 plus P of x is equal to 3 plus P of x is equals to 4 plus P of x is equal to 5. We have to find out. Instead of finding all these, what we can do is, this can be written as 1 minus P of x greater than 5. 1 minus P of x greater than 5. So that's why this is nothing but 1 minus P of x is equal to 6 is enough. That is equals to 1 minus, out of 6 trials, we have to get 6 times success. Success power 6 into failure power 0. So that is the way of answering a particular question. So this is another question they are asking like this. The question is given in this way. Find the probability of getting 5 exactly. Find the probability of getting 5 exactly twice in 7 throws of a die. 7 throws of a die. Find the probability of getting 5 exactly twice. 5 we have to get exactly twice. So probability of getting 5 exactly twice. 5 we have to get 2 times. That means getting 5 is a success. So that's why when a die is rolled, getting 5 is 1 by 6. Not getting a 5 is 5 by 6. Success how many times you have to get? Getting 5 exactly twice in 7 throws of a die. That means the number of trials is equal to 7. N is equal to 7. So we have to find out P of x is equals to 2. We have to find out. Out of 7 trials, success we have to get exactly 2 times. So P of x is equals to 2 is 7c2 into success 2 times into failure remaining times, that is 7 minus 2 is equals to 5. So this is one more question he is asking in this way. The question is given as find the probability of throwing at most 2. Find the probability of throwing at most 2 sixes. At most 2 sixes in 6 throws of a die. In 6 throws of a die, at most 2 times we have to get a success in 6 throws of a single die. Okay, right? At most 2 successes, maximum 2 times we have to get 6. That means getting 6 is a success. So that's why success probability here also 1 by 6, whereas the failure is equal to 5 by 6. Number of trials is equal to n, that is equal to 6. What is asking to find? P of x less than or equals to 2 he is asking. At most 2 times of success we have to get. Success is nothing but getting a number 6. So P of x less than or equals to 2 is nothing but P of x is equal to 0 plus P of x is equals to 1 plus P of x is equals to 2 we have to find out. So there is another question. In this question he is saying that the probability of a shooter hitting a target is 3 by 4. That means success is 3 by 4. The probability of a shooter hitting a target is 3 by 4. How many minimum number of times must he fire so that the probability of hitting the target at least once is more than 0.99. Probability of hitting the target at least once. Probability of hitting the target at least once is more than 0.99. Hitting the target is given as a 3 by 4. Success is given as a 3 by 4. Automatically failure is equal to 1 by 4. So P of x greater than or equals to 1 means what we can say? 1 minus P of x less than 1 is greater than 0.99. That means 1 minus P of x is equals to 0 is greater than 0.99. Now I can write 0.01 is greater than P of x is equals to 0. Number of trials we have to find out. Minimum number of trials. Let us say the number of trials is equal to n. So P of x is equal to 0 means out of n trials 0 times success. So success power 0 into failure power n. So that is the answer. Now this we can write it as 1 by 100 is greater than 1 by 4 to the power of n. Now I can write 4 to the power of n is greater than 100. This is true for n is equals to 4 cube is equal to 64. 4 is n is equal to 4, it is true. 5 also it is true. 6 also it is true, and so on. This inequality is true for n is equals to 4, 5, 6 and so on. He is asking the minimum number of times the shooter has to hit the target. That means minimum number is equal to 4. N is equals to 4. So here another discussion also we are going to do, but it is not in the syllabus, but better to know. That is called a Poisson's distribution. So what is a Poisson's distribution? Whenever the number of trials are large, more number of trials, definitely we are going to use this Poisson's distribution, but it is not in the syllabus. Better to know, that's all. So Poisson's distribution is given by x is said to follow Poisson's distribution if P of x is equals to r is equals to e power minus lambda into lambda power r divided by r factorial. P of x is equals to r is equals to e power minus lambda into lambda power r divided by r factorial, where r is equals to 0, 1, 2, 3 and so on. Whether you observed or not, here also P of x is equal to 0 plus P of x is equals to 1 plus P of x is equals to 2 plus and so on plus P of x and so on. It will go up to infinite terms. That means the next of x is number of trials is sufficiently large. So P of x is equal to 0 means what we will get if you take e power minus lambda common, then we will get lambda power 0 divided by 0 factorial plus lambda power 1 divided by 1 factorial plus lambda square divided by 2 factorial plus and so on. Now this is nothing but the expansion of e to the power of lambda. So e power minus lambda into e to the power of lambda, you will get e power 0 is equals to 1. So sum of the probabilities also you will get 1. So that is about the simple idea regarding the binomial Poisson's distribution. In Poisson's distribution, mean and variance are equal to that lambda. Lambda is the mean of the Poisson's distribution. So when I am discussing problems on binomial distribution and probability distributions, I will try to discuss one or two applications based on Poisson's distribution also. Okay, bye bye.